Hey, welcome to this lesson on applications of graphs in real-world context. Okay, we're going to look at one kind of graph, a few kinds actually. So the first one here we have is distant time graphs, and what is distant time graphs? It just simply means that one of the axes is distance and the other axis is time. So we have a very simple example here. A train left station A and travelled 8 km to station B. So we know that the total distance is 8 km, and the table shows the time in minutes of the train departure from station A and the corresponding distance travelled in km. Okay, so we have to draw the graph as per usual. So after drawing the graph and plotting the points, you should have something like this. And the thing is, you have to be careful because if the points are not like straight lines or anything, okay, and yeah, they actually ask you to actually join them with a smooth curve. This is where you need to be a little bit careful with joining them. So technically, since it's a distance time graph, you should start from 0 and go all the way up. Okay, so I'm just going to quickly show you all how this is done. Okay, I have to okay, I'm actually rotating my iPad as I'm doing this because it's a little bit of a hassle. Okay, so it actually goes up, but once it hits a peak, it actually turns. Okay, dang it. Nice smooth curve up. Just try your best to connect all the points in one line. If you can't, it's fine as well. Just do it point by point. I should have done it point by point just now. Trying to get this. Okay, great, something like that. Oh, okay, yeah, it's a bit wobbly. Okay, at this stage, actually, if you look at the points, right, it's actually coming to a plateau. Okay, so you need to start changing the direction of the curve. A little bit. Oh, okay. Okay, for this, you have to kind of be able to tell that the direction of the curve starts to change at this point. Okay, I didn't hit that. It's gonna take some time for you to actually kind of master this kind of drawing, but yeah, the graph should look something like that. Okay, and right now we have that we can right now estimate the time taken. So the question says estimate. We will actually take a variety of answers. So when the time is at the speed at 5 minutes, right? The first 4 km. So at the first 4 km, essentially by using the graph, we can draw a straight line that kind of that hits the distance where it's 4 km to the point where it's on the graph where it's 4 km, and kind of estimate that the time here is in fact about 3.8. Yep, so we can estimate that the time is in fact in this case 3. Oh, why did it turn back to? Yep, okay, the time here is 3.8 minutes. Okay, so we can actually answer part 2 quite easily. So part 2, time taken is 3.8 minutes. Okay, it depends on also how you draw. So there is going to be a larger range of plus minus here. So it depends on what kind of answers you get. Okay, so next we want to draw a tangent, and we're going to find the approximate speed of the train 5 minutes after leaving the station A. So in this case, we need to kind of understand that actually at 5 minutes is actually in fact, so it's actually this point over here, right? Okay, it's actually this point over here. Okay, let's draw a tangent. Okay, so what essentially is actually asking you to find the gradient. Okay, so the gradient of a distance time graph actually tells you the speed of the train. Okay, so for every kind of graph, it's different lah. Okay, so the gradient of a distance time graph, okay, tells you the speed. Okay, so that's why you're going to find the gradient at the point where time is equals to 5. In fact, if you draw a line, okay, I'm just going to draw a random line here to here. Okay, and of course this is not the line we want. We're going to kind of like see if this is the line I want. Not exactly, kind of like maybe somewhere here. Not exactly. I kind of have to move up a little bit. Okay, if you use a ruler well, you should be able to draw your tangent something like that. Okay, it should look something like that. Okay, in this case, this is part 3, so you indicate that this is part 3. And let's approximate the speed of the train. So this would mean this is the gradient. So I'm going to use 2 points. The first one I'm going to use actually this point over here. So this point over here is very simple. It's simply 5, 6.8. What I'm going to do is choose a second point that's relatively easy, and I think I'm going to choose this point over here. This point over here is simply 3, 5. Okay, somehow I managed to like do something nice. So we can actually find the gradient now with 2 points. So part 3, the gradient is gradient will be equals gradient of tangent. Okay, let's make it more specific. Okay, I'm gonna give 5 minutes. Okay, is equals to y1 minus y2 divided by x1 minus x2. The gradient of the tangent at 5 minutes is 6.8 minus 5 over 5 minus 3. But what you need to bear in mind is that the answer that you have here is 1.8 km, is in terms of km, over 2 minutes. Okay, and the thing is, this question will require you to talk about speed, and speed is in fact in this case km per hour. So what I'm going to do is going to express, this is 1.8 km per minute. Okay, sorry, this is actually 0.9 km per minute, which is in fact not what I want. I want it in terms of hours, and if I want it in terms of hours, this means I have to multiply it by 60. Right, I have to multiply it by 60. So if I have to multiply it by 60, that's pretty straightforward here. Okay, so 60 times 0.9 is actually 9 times 6. 9 times 6 is 54 km per hour. Okay, for this question, you will have a very big range of like in terms of all your tangents, you will have a very big range. So don't worry about it. Okay, it's natural to have a very big range of answers. I'm looking at probably a plus minus of 20 km per hour. Yeah, I'm looking at around that big because of the way it is computed. Okay, so you don't have to worry about it. Okay, so now part 4, by considering the gradient of the graph, compare and describe briefly the motion of the train during the first 4 minutes and the last 4 minutes of the journey. This is pretty an interesting question because right here we kind of want to look at the gradient actually. As I said, the gradient actually is the speed of the train here. So in this case, let's draw a few gradients. Okay, so let's say I have I'm just gonna draw a small one. So this gradient here, okay, it's at here, right? At this point, it should be somewhere here. Okay, and then I have a gradient here at this point. As you can see, for the first 4 minutes, right? Can I say that the gradient is in fact increasing? It's getting steeper and steeper, right? Okay, just pay attention here. The gradient of all the points for the first 4 minutes is actually getting steeper and steeper. However, when you go past the 4 minutes, in fact the gradient gets less steep, right? So if I have, this is the let's consider a gradient here. Okay, there's too much things going on. Okay, so maybe I have it here. Okay, can you see that now after the 4 minute mark, the gradient gets smaller and less steep, right? The gradient here gets less steep. Compare these three gradients here. So 1, 2, and 3. So what can we conclude from this? So if gradient is for this graph, it corresponds to speed, we can in fact say that the gradient speed is actually increasing, right? Because since the gradient, okay, since gradient increases, right, for the first 4 minutes of the journey, this speed of the train increases, because this is what we're talking about, the speed, right? Okay, but however, gradient decreases. Okay, I'm going to use arrow, decreases for the last 4 minutes. So the speed of the train decreases. Okay, so for this kind of questions, it's very important to understand what we mean about distance and time graphs, and what does the gradient actually mean for these kind of questions. Okay, so that will be all for work example 7. Thank you.